This is Geometry Unit 4. We're going to learn about proving triangles congruent by RHL. Right triangle, hypotenuse leg. This first part is a construction. We'd be trying to find the perpendicular bisector. One way we can do that is with a compass, is by what our directions talk about. I don't have a compass on me. Another way we can do it is to fold our paper so that our endpoints line up together. Crease the paper, and now we have this perpendicular bisector. It should cut it in half, and it should form a right angle with AB. We're going to pick a point on here called point C. And one thing that we're going to recognize is that it's equidistant to both endpoints. No matter where you pick on this perpendicular bisector, it would still be equidistant to both ends. So there's a perpendicular bisector theorem. In a plane, that means on a flat surface, if a point is on a perpendicular bisector of a segment, then it is equidistant. It's not equal, it's equidistant. If CP is the perpendicular, that means it forms a right angle, and it's the bisector of AB, that means it cuts AB into two equal pieces, then CA is the same as CB. We'll call that equals, and we don't need the line above them. On the next page, we're looking at a proof. We know that CP is a perpendicular bisector. What we want to prove is that CA is going to be equal to CB. Our given tells us that it's perpendicular bisector. We know that P is going to be the midpoint if it's the bisector. So if a line is a perpendicular bisector, then it intersects at the midpoint. Remember what the then means. Then means it's happening right now. And what they're stating right now is that P is the midpoint. Then it's the midpoint. Then means it's happening right now. So that's how we can write that. If a point is a midpoint, then it divides it into two congruent segments. I know that I have AP congruent to BP. It's because P is the midpoint. That means it breaks this segment AB into two equal pieces. We've talked about how we have perpendicular lines. If we have perpendicular lines, then we know we have angle CPA, comma, angle CPB are right angles. We look here again. Then says right angles. We need to talk about right angles. Down for number 5, it says if you have right angles, then you have congruent angles. Then congruent angles. We have to talk about congruent angles right now. So angle CPA is congruent to angle CPB. We also have the reflexive property. Where in the picture do we have a reflexive property? CP is going to be congruent on the triangle to the left to the same thing, CP on the right. That's called the reflexive property. So now we know the two triangles are congruent by side angle side. And if we know two triangles are congruent, here's a new term for us. If two triangles are congruent, then the corresponding parts are congruent. Remember what congruent triangles are. They are two triangles with the same size and shape. So if we know that CA are the first two letters and CB are the first two letters, then I know for sure that CA is congruent to CB. If they're congruent to each other, they're also equal. If segments are congruent, then they are equal. So that proves, regardless of the size or shape of what we're dealing with, if we have a perpendicular bisector, that those other portions are definitely going to be congruent to each other. We've learned 4 ways to prove triangles congruent. We've learned about angle, angle, side, angle, side, angle. Those are the ones we've learned most recently. Side, angle, side, 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 side. Those are the 4 ways that we've learned so far. Right now we're going to learn about RHL. These are 5 ways to prove triangles congruent. If the hypotenuse and leg of a right triangle are congruent to the hypotenuse and leg of a second triangle, then the triangles are congruent. We're going to call this RHL. Right triangle, hypotenuse, leg. We'll put that right here. Right triangle, hypotenuse, leg. Those are the 3 things we would need to show in order to use RHL. Here we know we have perpendicular sides. YW is perpendicular to XZ. That means we have right angles. And we know that XY is the same thing as YZ. Notice I'm making a plan before I start writing it. And I also have the reflexive side, the side that they have in common. So typically we would look at this one and think that it was angle side side, ASS, but we've learned that that is not one of the ways we can prove triangles congruent. But in a right triangle, that can work, but it's special to a right triangle. So we call it right triangle, hypotenuse, leg. So, number 1, we know that YW is perpendicular to XZ. We also know that XY is congruent to ZY. That is part of our given information. If we have perpendicular segments, then we know we're going to have two angles that are right angles. If segments are perpendicular, then, okay, then is happening right now. Then they form right angles. If we have right angles, then we know that triangle XWY and triangle ZWY are right triangles. If right angle, then, okay, then happens right now, right triangles. If you have a right angle inside a triangle, then you know that that's going to be a right triangle. Why is it important to talk about the right triangle? Because if you're going to use RHL, the R stands for right triangle. It doesn't just stand for right angle, it stands for right triangle. We know we have the reflexive property. So we have the two segments that share each other. The two triangles share the same side. And that is going to be enough for us to show that these two triangles are congruent. Notice that up here, XY, that was our hypotenuse. Here we showed the triangles were right triangles, and this is one of the perpendicular sides, which is a leg. So we have R, H, and L.